Hey folks, this is question 7. First one, estimate the value for one share on the 1st of March. You just have to look at March, and if you draw a line up and across, it will be between 7 and 8 there. So the value of shares of, say, €7.4, €7.40. Next, we use the graph to identify the month during which the value of one share increased by the greatest amount. So we're looking for the biggest jump here, and it has to be May to June. That's the highest slope. Okay, so that's the biggest jump there is. So May to June, so June. Yeah, it was May that it increased. So because it's for each dot represents the first day of each month, so it's going to be May that it was increasing in. It got from May, and then by June, by the 1st of June, it had increased a lot. Next question then. On the 1st of August, it was 15% lower than on the 1st of July. And we have to find out what it is in August then. Well, if we look at July, you can see that in July it was 8. It's on the line for 8, so it's €8. We're going to find 15% of 8 and see what it is. And it's 1.2. So if I do 8, because it decreased, it was 15% lower, so 8 minus 1.2 is 6.8. Therefore, it's 6.8 on the 1st of August. And we'll just go up to 6.8, which is about here. And then you have to draw the line down. And the formula for percentage error is the error over the real value times by 100. So if I fill that in here, the error this time is 150. I'll call the bottom bit X because that's what we're actually looking for the actual value of the share. And if you times that by 100, that should give us 16.3%. Well, just 16.3 because it works out what the percentage is, so it's not actually percentage. So equals 16.3. If I bring across the 100 and divide it, I'll get 150 over X equals 16.3 over 100. If we cross multiply, it's always the easiest. 22 fractions multiplied by each other, you'll get 150 is equal to 16.3x. And then bring across to 16.3 and divide it. And that will be equal to x. And when we round it off, it's 920. Right, this one, we just have to sub in each value into the m, into the power there. And the first one will be 2.58. Then put in a 3 instead of it. 4.29. Then a 4 instead. It's 5.54. And if you put in a 5 instead, it gives you 7.14. Then you have to plot them on the graph. higher enough to see them here on this, but you just have to take your time. So something like that, and just join them up. And at only one point in time is the value, are they equal to each other? They always ask for this. If we look at where the two lines cross, it's very close to 4. So I would say maybe 3.9. There'll be a bit of a tolerance for that anyway. You don't have to have it exactly. Right, then part E, it decreases by 30 cent per every month. So it decreases 0.3 for every n. So after 1 month, it's 1 times 0.3. It decreases by, after 2 months, it's 2 times 0.3. It decreases by, and so on. So we just need to see at what point did it start to decrease. And if we just look back up, that's going to be, was the last point, it's the 9.2, or it's this place here. So 9.22. And using the expression, or otherwise find how many months it takes for the value to fall below its value on the 1st of January. Well, on the 1st of January, it's 2. Therefore, we're going to let it be less than 2. So where is 9.22 minus 0.3n? Less than 2. So bring the minus 0.3n to the other side. 0.3n is greater than 9.22 minus 2. That's 7.22 is less than 0.3n. And if I divide 7.22 by 0.3, it gives me 24.07. N is greater than 24.07. Therefore, it would take 25th month. So 25 months.